fourth grade. This video is going to focus on division. The first division strategy we have is partial quotients. Here we have 93 divided by 4, which we can rewrite that as 93 divided by 4. 93 is my dividend and 4 is my divisor. Our goal is to create groups of 4 out of that whole amount that we have of 93. So I wonder how many groups can I create with 4 items in each group. So let's see, we're going to do some long division here to help us figure that out. So I'm going to first take a look at the first digit I see, which is a 9. 4 times some number is going to get me close to or exactly to 9. So I know that 4 times 0 is 0, 4 times 1 is 4, 4 times 2 is 8, and 4 times 3 is 12. So 8 and 12 are both pretty close to 9, but if I chose 12, that's way too big, and 8 is not exactly 9, but it's really close to 9. So I think we're going to use 8. Now here's the thing, 4 times 2 gives me 8. Now notice 8 got me close to or exactly to 9. Now in this space here, that missing spot here, we need a digit. We need to put something here. And a digit that doesn't have any value is 0. So I'm going to place a 0 in my work and a 0 in my answer. Now I can confirm that this is correct because 20 times 4 is actually 80. So 0 and the 8 together creates the number 80. And 4 times 20 is 80. So now I'm going to subtract and I'm left with 13. So now I see that I have 13 things left. I can continue making groups of 4. So in the previous problem here, we learned that 4 times 3 was 12. And we love 4 times 3 because notice 12 is close to or exactly to 13. So 4 times 3 is 12. I'm going to subtract and I'm left with 1. Now I know I'm finished. I know this is my remainder because when I look at that one individual item I have left, I can't make another group of 4. There's not enough to make a full group of 4. That 1 is my leftover amount or my remainder. Now notice this remainder is also always less than my divisor. Now to determine my final answer, let's do this in red. I'm going to look at my answer choices. I have 20 plus 3. So on the side, I can do 20 plus 3, which happens to be 23. Now, 23 is my quotient, but I can't forget about my remainder of 1. So here my answer is 23, remainder 1. Now, what I love about division is you can always check your work with multiplication. So let's see if what I did was correct. What we can do is we can actually take my quotient and you can multiply it by the divisor. Now, I'm going to take 23 times 4. Let's see what we get. So here when we're multiplying, we get 92. Now, I notice that's pretty close to my dividend, but I can't forget about this remainder of 1. So now I'm going to add my remainder of 1, which is going to give me 93. And I notice 93 is also my dividend. And that's your goal. That's how you know you did your division problem correctly, is when you get the same answer as your dividend, when you multiply your quotient by your divisor. And here that's proving that we did this correctly. In this next problem, we have 912 divided by 5. We have 912 as my dividend, 5 as my divisor. Now let's do my first step in blue. I'm going to focus just on this 9 here. 5 times some number gets me close to or exactly to 9. Well, 5 times 1 is 5. That sounds great. 5 times 2 is 10. That's closer to 9, but the thing is we can't go over 9. So we're going to use 5 times 1, which is 5. Now before I subtract anything, what I'm going to include here is we have 2 digits here. Those digits are going to be a 0 and a 0. Now, if I include 2 zeros in my work, I'm going to include 2 zeros in my answer part. Now, what I'm going to do is subtract this entire amount. 2 minus 0 is 2, 1 minus 0 is 1, and 9 minus 5 is 4. So we get 412. Now we're on part 2. So part 2 is going to look at the first 2 digits now. So So 5 times some number is going to get me close to or exactly to 41. So 5 times 8 happens to be 40. That's wonderful. That's really close to 41. So what I see here is a missing digit. We're going to include a 0. Now, if I include a 0 here, I'm going to include a 0 next to my 8. Now, again, we can confirm that this is correct because 80 times 5 is 400. Now I'm going to subtract and I'm left with 12. I'm getting really close here. So now my last part here is 5 times some number is going to get me close to or exactly to 12. Well, 5 times 2 is 10. 5 times 3 is 15. Well, that's too big. So 5 times 2 is 10. Let's subtract and we're left with 2. Now I know I'm finished because I have only 2 things left and we're creating groups of 5. So with those 2 remaining pieces, I can't create another group of 5. So I am finished. That is known as my remainder. Now, by looking at all this work, you're really close to being done. Now my last piece is to add these numbers on the side. So I have 180 plus 2, which is 182. Now notice 182, this is 182 in expanded form. So now I have 182 as my quotient with a remainder of 2. We can't forget about our remainder here. It's also very important to include that in your final answer. Now again, to confirm that this is correct, we can use multiplication. We can actually do 182 times 5. So let's see what happens when we do this. So I have 41. 5 times 1 is 5, plus 4 is 910. Can't forget about my remainder of 2, giving me 912, which I notice is the same answer as my dividend. That's how I know I did this correctly. So if you are curious if what I did was correct, you can always use multiplication to check your work. Our next problem here is a little bit different. We have 207 divided by 6. Now, we're going to take it one digit at a time. I look at the 2. And I'm like, 6 times 0 is 0. 6 times 1 is 6. That's a little too big. We want close to or exactly to the digit 2. Now, you can, in fact, use 0, and then you would have 0, 0, 0. You subtract, and you'd be left with 207 again. So you can include all those zeros, and that's fine. But in this situation, you can actually look at the first 2 digits. So 6 times some number gets me really, really close to 20. Well, 6 times 3 is 18. That's great. 6 times 4 is 24. That would be too big. So let's subtract. Now, before we start our subtraction, we're going to also include a digit here. We're going to include a 0 and a 0 here. Now, 30 times 6 is 180. That confirms we're correct. Now, when we start subtracting, we have my zeros in place. I subtract, I borrow, no biggie. So now I'm borrowing and we're left with 27. Now, what's great here, we're super close. We have 6 times some number gets me really, really close to 27. Well, 6 times 4 is 24. 6 times 5 is 30. That's a little too big. So let's go with 24. When I include here, notice I have no digits, no special and extra spots here where I need any zeros. I subtract and I'm left with 3. Now we know 3 is right because we look at my divisor. We're creating groups of 6. Now I see here when I'm creating these groups of 6, I can't create another group of 6 with just the 3 left over, so I'm finished, and that's known as my remainder. But as we learned from the previous problems, we're close to being done. My next step is to simply add the numbers on the side. 30 plus 4 is 34. So my quotient is 34, remainder 3. Now, to confirm that what I did is correct, we can use multiplication to check our work. So 34 times 6, notice I took my quotient times my divisor. When I multiply, check out what I get, 204. Now I'm pretty close, but I notice there's a remainder in this problem. So if I add 3, I'm left with 207. And notice 207 here is the same as my dividend. That means what I did is correct. So this problem is done using partial quotients, which is really, really amazing. So there's also another method we've talked about as well. So the next method for division is called the standard algorithm. Now, you might have saw that I almost started to do it in that previous problem. So we're going to take 207 and we're going to divide by 6. I'm going to set it up the same way that we just did. Now, notice here, it looks very similar. We're not going to draw a line down the side, but we're going to do a different method. And for many of you who maybe learned this over the summer with somebody else, maybe your parents started teaching you some of these methods, they most likely taught you the standard algorithm. Now, in 4th grade, we have to master the standard algorithm and partial quotients. We have to be able to tell the difference between the two and really be able to break our division problem into pieces. So it's important that we are able to do both of these methods. But I see that some of you are starting the standard algorithm. So let's take a look here. Now, the first thing you're going to do, just like the previous problem, we're going to take it digit by digit. So 6 times some number gets me really, really close to 2. Now, for this one, I am going to write the zeros because I want to show you this step. So instead of putting a number on the side, I'm going to put it on top, right above that 2. So 6 times 0 is in fact 0. If I use 6 times 1, I would have 2 minus 6, which we can't do that. So 2 minus 0 is 2. Now, I'm getting close, but notice I have another digit. So I'm going to take this digit by digit. So instead of using zeros to fill in that space, I'm going to use an arrow. I'm going to take it one digit at a time. So if I bring down this arrow, I'm bringing down that digit. So I'm bringing down this 0. So now I don't just have 0, I have the number 20. So now I'm deciding 6 times some number gets me close to or exactly to 20. So 6 times 3 actually happens to be close to exactly to 20. That's 18. So now notice we used that 3 before as well. So now I'm going to subtract and see if anything's left over. I'm going to borrow here, and I'm left with 2. But notice I still have another digit here. So instead of adding a 0 here in place, we're just going to bring that 7 down, which we're going to bring that 7 down with an arrow. So this arrow is going to stop here because this 7 is now going to create the number 27. So now I have to decide 6 times some number gets me close to or exactly to 27. So 6 times 4, in fact, is 24. Now, again, we use these same numbers for the last problem as well. So 27 minus 24 is going to give me a remainder of 3. Just like the previous problem, I know I'm finished, which is great. I know I'm done because 3 is less than my divisor. I can't make another group of 6 with those 3 leftover items. So again, I have to include my remainder here at the top in my quotient, and I have 34 remainder 3. So some of you might see it written like this, but notice this is exactly the same as 34 remainder 3, which in fact is my answer to this problem. Now, if I go back and forth and I see, well, I got 34 remainder 3 as well. Now, both methods get you the correct answer. Both methods are excellent ways to solve these problems. Now, both methods you will be using this school year, which is why it's important to work on both methods. Now, for the activities this week, I really want you to try partial quotients and really master partial quotients. And then next week, we're going to work on really mastering the standard algorithm, which I truly believe with practice, you will all be able to do. So as always, you can refer back to this video at any time to help you with any activities regarding division.